Year 9s and welcome back to another video. As you remember, we did particles and how to behave with different energies in the last video. So today we're going to build on your knowledge that you've gained in the previous video, and we're going to talk about expansion and contraction. Right, so expansion is when something swells up or gets bigger, and contraction is when it shrinks down. So we'll have a little bit of an experiment. I'll quickly show you a demonstration, and then we'll talk about why do you think what you see is happening. And we're going to apply some scientific principles behind it. Right, so what we have here is a bottle with a balloon attached to it, and remember we said everything around us, although we can't see it, has particles. So at the moment we have gas particles in this balloon, in the bottle and in the balloon. And what we're going to do, hopefully you can all see there's no system, there's no way of the air still coming in, more particles coming in. And now what we're going to do is we're going to put it in the hot water and just see what happens to this balloon, and then put it in the cold water and see if there's anything else that happens. Okay, so the first one, we're going to put it in the balloon, in the hot water. Hopefully you'll be able to see the balloon inflate. Okay, so it's getting bigger, right? And then when I put it in the cold water, it's deflating, so it's getting smaller. And we'll see, add a bit more ice to the sides, cool the bottle right down. And you'll see there's almost like nothing left in the balloon. And then if we put it back in the hot water, it's like magic. So let's try and explain what happened to the bottle and the gas and the particles inside the bottle and the balloon in the hot and the cold water. Okay, so for instance, if we have a bottle and we have the balloon at the end, what's going to happen is, remember gas particles, the particles are far apart. So this is now before it gets heated, so there's some particles still left in the balloon and some particles in the bottle. And then when we heat this bottle up, remember we said what happens to particles when we heat it up? So if it's in hot water, what's going to happen is this hot water is going to heat up the bottle, and it's going to heat up all those little particles as well. And remember, heat is a type of energy that we can give to particles. So if we give all these particles energy, what's going to happen is they're going to start moving faster and faster and further apart. And because this is a closed system and there's nowhere for it to go, the only easiest path for it to go, so they are going to start moving. So the amount of particles is still the same, but it'll start moving a bit faster and further apart. So they are spreading further apart. They want to go further, but because there's nowhere else for them to go, they go into the balloon. And that's why the balloon is inflating. So with a lot of energy, particles are moving faster, spreading out further, and then they go into the balloon, and that's why it's inflating. The opposite happens in the bottle that's in the cold water. So if we have the bottle in the cold water, put that in the cold. Now these particles, it's moving like crazy because they got a lot of energy, they heated up. Those particles are now cooling down. And cooling down is like the opposite of heating, energy-wise. So cooling means I'm taking all the energy out of the system, out of them. And what happens when you don't have a lot of energy when it's cold on a cold, windy, winter's day? What's happening is you want to try and huddle and come as close to the people around you as possible to get a little bit of heat. And the same goes with particles. When they cool down, they want to come closer together because they don't have a lot of energy. So now they're not moving as much, they're just vibrating slower and closer together. So these particles are now moving closer together. And because that happens, all this empty space is around where these particles are moving into the balloon, into the bottle, and that is why the balloon is deflating. So that is also its contraction and expansion, getting bigger and getting smaller, and that's all because of the amount of energy that these particles have and the amount of movement of these particles. So why is it important to know about expansion and contraction? For instance, at home, an example would be if you cook and you have a glass bowl or a dish that you've put in the oven that's hot and you put it into cold water. Hopefully none of you have done it before, but what happens is this glass shatters or it cracks, and the reasoning behind it is because of contraction and expansion. So imagine this is your glass dish and you have your particles that's a solid, so they're close together. But because they're hot, they're moving as much as they can for a solid. So they're moving, and as soon as you put it into cold water, the outer layer on the outside starts cooling down, which means that all these particles on the outside starts cooling. And remember what we see with particles that cool down, they contract and they get closer together. So if these particles are closer together and the inside is still hot, the inside will still be moving and the outside is vibrating slower. What's happening is this difference between the behavior of the particles causes a crack or a shattering of the glass in this bowl. Another example is if you have rings on your fingers and the rings are stuck on a hot day and you can't get them off. What do? You either use soap water or you heat up the ring. And because the ring is a better conductor of heat, the rings will heat up easier than your finger would. And because you heat something up, the particles start moving a bit faster and it expands and it gets bigger, and that's how you can get your rings off. So hopefully now we know a little bit about expansion and contraction, getting bigger and getting smaller based on temperature, and we can understand and explain in science words and terms why things get bigger when they get hot and why they get smaller when they cool down again.